Welcome to today's webcast. This call is being recorded. And now to begin the program, I'd like to introduce Chris Flack. Please go ahead.
Hey, thank you so much, Talari, and welcome everybody in our audience to today's webcast. Make your storage work for you. VAAI and ODX offload up to 30% of disk operations to the SAN, sponsored by StarWind Software. I'm Chris Flack with Redmond Magazine, and I'll be your host for today's event. So thank you all for joining in the audience. We greatly appreciate that. Quickly, before we begin today's presentation and introduce our speakers, just a couple reminders. We will have a Q&A at the end of today's webcast. However, we encourage you at any portion, during any portion of today's webcast, if you have a question, please feel free to enter it via the Ask a Question box appearing on the left-hand side of your console. And hopefully, if time permits, we'll get to everybody's questions and get out some answers. Also, we'll have a recording of the webcast available within 24 to 48 hours after today's webcast. We'll send you a link to the email you registered with that link, so that way you can share that link and view that link for previous replays. Share that link with coworkers, colleagues, and friends, anybody who may be interested on today's topic. We'd greatly appreciate that, so thank you for doing that. Joining us for today's webcast, we have two really great presenters. Just a little bit quickly about some of our presenters. You're going to hear a bit today from Aidan. He's a technical sales lead with Micro Warehouse. A little bit of background on him. He's got Windows Server and desktop management background, along with virtualization, Azure, and IT infrastructure. You can reach him on his websites or blogging and writing at aidanfid.com. You can also copy those links down if you want to check him out. Also, you can reach him on his Twitter handle up there. He's just a wealth of knowledge, and you're going to hear a lot from Aidan today. Also joining us for today's webcast is Kolomyeytsev. He's StarWind's Virtual SAN product manager. A little bit about him. He's got 8 years of QA and technical support. You can reach him at StarWind on Twitter. He's got 10 years of professional IT experience, and he's the host of StarWind's webinar series, and he hosts all the StarWind webcasts with us here at Redmond Magazine. Without any further ado, I'll let the guys take over their presentation. So, guys, why don't you get started?
Cool. Max, shall I get going?
Yeah, I think we start with ODX, which is Hyper-V's way of offloading storage to storage.
Yep, so hi everyone, I'm Aidan, and I'm happy to be here with StarWind talking to you about ODX in a Microsoft Cloud scenario. So it's a given. I think everybody understands that the way we're consuming data and generating data and retaining data has changed. We're producing more data than ever before, and we're keeping it for longer than ever. Also, what's changed is how the business is perceiving IT. In the past, the tail wagged the dog. IT drove the speed of business, and now business expects IT to operate at the speed of business. So administrators are going to have to do stuff more quickly. They need to be able to get operations done as fast as possible. They can't give excuses to the boss anymore because the boss just doesn't accept them. And we also are seeing in medium to large environments where faster self-service deployment is required. So self-service is one of these key traits of a cloud, and people aren't going to sit there waiting for hours for a virtual machine to deploy. They want it to happen as quickly as possible. They're not going to wait for or accept the fact that, a virtual hard disk takes ages to create when they're looking for more space or more capacity or to deploy a new service. So we need to be able to adapt to all of this. We can see a couple of examples of this. The first is, a simple scenario where we've got a Hyper-V host that's connecting to some sort of SAN. In this case, it's over a nice SCSI connection. And we want to either create a fixed virtual hard disk or extend a fixed virtual hard disk. Now that process is slow. Anyone who's worked with Hyper-V knows that creating or extending a fixed virtual hard disk is one of those things that you do either at lunchtime or at the end of the day. And what's going on in this case, or why is it slow? Well, the virtual hard disk is being extended or created one block at a time, and then it's being zeroed out. That zeroing out process is securing or erasing the underlying data that may already exist on the physical LUN, so that the guest OS administrator can't do a scan to find any data that may have been there. That's pretty important when you're in a multi-tenancy environment. Another scenario where we see some of this slowness is when we're deploying a virtual machine using System Center. So we may have System Center Virtual Machine Manager library stored on a LUN in a SAN. And from that virtual machine console or virtual machine manager console, we could deploy a virtual machine. The library server is going to read the fixed virtual hard disk or the virtual hard disk from the LUN on the SAN, and then transfer the blocks over the Ethernet to the Hyper-V host, which in turn writes the blocks down to another LUN on the same SAN. So we're seeing those blocks traveling a long distance and over a latent network connection to get from the library server's LUN to the host's LUN, where the virtual machine is then instantiated and then enters the out-of-box experience. So Microsoft introduced ODX, or Offloaded Data Transfer, in Windows Server 2012 as part of their enhancements to add value to customers who are using or deploying SANs. What we get is an offloading of relatively slow operations from Windows to the hardware, and allowing the hardware to do disk-to-disk operations instead of sending data across an Ethernet or across a latent iSCSI connection or whatever. And it just speeds up the entire operation for the administrator and hopefully the customer as well. We just end up with much faster operations and happier customers. So examples of where we're seeing this is Hyper-V using ODX for those disk operations that we just talked about, and also System Center 2012-R2 introducing ODX support in the form of fast file copy. So we're able to transfer files from the library server to hosts very, very quickly by, well, not transferring the files between the two servers. ODX works by using a token system. So a token is sent from the source server to the recipient server, so there's an authentication and a validation of the data that's about to be transferred. And then the SAN either does a disk-to-disk or an internal disk operation, so data never actually transfers between the source server and the destination server. It stays within the SAN, or potentially even goes from SAN to SAN if we have supporting hardware. So, benefits. We see much faster disk operations. So you want to create a fixed virtual hard disk? Well, that's going to be much faster. A friend of mine's recorded some demo videos where he's creating 1 terabyte fixed virtual hard disks in a matter of seconds instead of hours. We can extend fixed virtual hard disks, so if you want to do that online resize really quickly in 2012-R2, you're going to be able to do that. You want to move a virtual machine from one LUN to another and minimize the impact on other virtual machines on those LUNs and get access to more space as quickly as possible. You're going to be able to do that with live storage migration, taking advantage of ODX. Or merging checkpoints. Checkpoints used to be called snapshots in the past. Now we know them as checkpoints. And they're used in lots of different scenarios for file-based backups. They're being used in Hyper-V Replica, and people are using them in DevOps as well. That merge process now can be really, really quick by taking advantage of ODX. And in a cloud scenario, in those medium to large environments or in the hosting environments, you're able to deploy virtual machines more quickly, and customers who are deploying it through a portal are going to have a faster provisioning of services. So they're going to be happier customers. So if we look at the scenarios that we looked at before, we have the Hyper-V host, which is now creating a fixed virtual hard disk really, really quickly. And in the System Center scenario, we have fast file copy. So when VMM realizes that it has ODX support between itself and a host that it's deploying a virtual machine to, instead of sending the file across the LAN, we have a disk-to-disk operation within the SAN. There's some hardware requirements if you want to use ODX. Well, the first is you need a SAN that supports ODX. So you need an iSCSI SAN, Fiber Channel SAN, or FCOE, or a SAS attached SAN that has support for ODX. And it's always good practice to make sure that you've checked with your SAN vendor, that you're making sure you're going to do everything right and you have support for doing what you want to do. And also make sure you upgrade the firmware and drivers throughout the entire stack, from the disk, the trays, the SAN controllers, all the way through to the HBAs, and even the servers themselves. Make sure the entire thing is updated, both firmware and drivers, because there's always bugs and there's always bug fixes. Make sure you have a fully compatible stack. And then there's software requirements. You're going to need Windows Server 2012, Windows 8, or later, because you can actually do ODX transfers using Windows 8. If you're using System Center, you're going to need System Center 2012-R2, where we got the fast file copy feature for the first time. If you're using any antivirus or encryption software, then their filter drivers must opt in to supporting ODX. The volumes must not be dynamic, they must be basic, they must be formatted by NTFS. You have to disable data deduplication and BitLocker on those volumes, and storage spaces is not supported. The files that you're hoping to optimize, they have to be 256K or larger, And preferably, they're not going to be highly fragmented, because if they are highly fragmented, you're going to lose all the benefits. In fact, let's face it, you're going to lose any performance anyway by having fragmented file systems. There are a few interesting deployment options or alternatives to some of the normal things where you might consider using ODX. Virtual machines can actually take advantage of ODX, the guest operating system within those virtual machines. So if a virtual machine's guest OS is directly connecting to a LUN on the SAN, maybe using the iSCSI initiator in Windows OS, or using virtual fiber channel, then ODX is also available to those machines if they want to do disk transfers or disk operations. You can also build a scale-out file server that supports ODX. Now remember, I said storage spaces wasn't supported. However, you can build a scale-out file server using a SAN. And if that SAN supports ODX, then your scale-out file server can support ODX. And then Hyper-V can take advantage of that as well. And in a very large environment where you've got multiple SANs, in theory, if your vendor supports it, you can do inter-SAN data transfers that take advantage of ODX as well. And that can really speed up some of your operations. However, be aware that not all SANs offer the same level of support for ODX. So some SANs support it, but it might not be stable. So we always recommend that you validate and test any feature like this, any hardware offload. So things like VMQ and network cards and ODX and storage. We always recommend that you validate and test this to make sure that it's stable and is giving you the performance you expect. And if it's not, follow up with your vendors, check with the support forums, make sure you've got everything up to date and you're doing best practice. And if you still have problems and you find that it's still unstable, you can disable ODX. That's a registry entry. So go to HKey local machine system, current control set, current or control file system, and create a value called filter supported features mode and set it to 1. That will disable ODX on a server or a host. We also have found in real world experience that some SANs offer amazing performance and others offer very little. And those that offer very little, maybe you might even consider just disabling it just to be on the safe side. Where it works well, it works amazing. And it is something that is going to offer some great benefits to you as an administrator and to your customers, be they internal or external. Max, you want to talk about VAAI in the VMware world?
Yeah, let's jump to VMware world. Thank you for the great ODX presentation. And VAAI is essentially ODX for vSphere. I'm not sure which one appeared earlier, but I guess vSphere VAAI or VMware VAAI to be more correct. It was released a little earlier than ODX. So this is the direction where hypervisors are moving, and they're becoming faster, more flexible, and a little bit more lazy and smart on storage operations. So instead of doing the copying work and some boring work by themselves, the hypervisor actually offloads all that process right to the storage array. So VAAI is VMware's prime technology for doing that, and it speeds up all the operations which may seem boring to the array, like cloning a virtual machine, provisioning drives, or zeroing the drives. And what's the benefit? The benefit is that previously we used to do a lot of transactions between storage and the actual hypervisor to perform, let's say, a cloning task. The hypervisor had to read the virtual machine data and then write it into a different place on the storage. Right now, it doesn't need to do that. It just sends a command to the storage to copy some data from one location to another or to add certain data. And this allows us to save a tremendous amount of resources for our production environment. So next time when you copy a virtual machine or you do a storage vMotion and your array does not support VAAI, don't wonder if your production virtual machines start to slow down. And one more noticeable thing about VAAI is that it now uses standard T10 commands, which means it's all native iSCSI. There are no commands which are non-standard. So this is a good thing about standardizing the whole VAAI approach to storage. Now, first thing in VAAI I would like to mention during today's event is ATS, or atomic tests. It's what VMware now uses to replace the SCSI persistent reservations. So that may sound too technical for you, but let me give you a basic overview. Previously, with SCSI reservations, we had a certain storage resource, like on the left side of our image. We have two ESXi hosts running one virtual machine each, and those virtual machines reside on one LUN, somewhere in the shared storage array. So I simplified the diagram as much as possible. Now, when virtual machine 1 updates its metadata, virtual machine 2 cannot do that because of the SCSI reservation lock, which is applied to the entire LUN. Now, this caused certain issues when there are more than one virtual machine. And in reality, there are more than 10 to 50 to 100 virtual machines running on, let's say, one data store. And to overcome that, VMware released a primitive called ATS, which only locks certain blocks and prevents these metadata update locks to the entire LUN. So right now the metadata is updated for each virtual machine individually, causing less overhead and not causing the virtual machines to wait until the reservation is released and another host can access that LUN and modify the metadata. And since we already talk about Atomix, we can basically compare that to having all your LUN closed by a fellow shelter door, or having a fine-tuned procedure like number of buttons on the picture on the right. These are used to control the nuclear reactors, to push and pull the fuel rods in and out. So as you can see, the right gives you much more sophisticated control, and it's automated, so you don't need to control that, and you're not responsive for the consequences. Now, next interesting command in VAAI is XCopy, or extended copy. So on the left side of the picture, we see how it used to be earlier with vSphere 3.5 to 4.0 without VAAI. So when we had to do a storage vMotion or cloning procedure from one LUN to another, or logical unit 0 and logical unit 1 on this picture, we first had to read the information to the host, then process that information and write it to the LU1. Right now, with VAAI enabled, we simply send a command to the storage array to write that information from one place to another, and this procedure does not involve the hypervisor that much anymore. So basically offloads a lot of CPU cycles, RAM, which are so needed for high-dense virtualized environments. Now, this is one of the most demanded options after the ATS primitive. Then, there are some more commands which I would like to go through real quick to give you an idea. What else can we simplify? What else can we offload off the hypervisor and make our storage work for us? Those may be the commands you do, well, actions you do every day, and you don't even suspect that it causes some overhead on the SAN. When you are doing an eager zeroed BMDK, you start the procedure, and then without VAAI, the hypervisor and storage simply exchange commands like write me a 0, okay, write me a 0, okay, and that lasts quite a long time. Aidan mentioned that the times with ODX were different by order of magnitude. Same happens with VAAI. When you provision eager 0 VMDK with VAAI enabled, it doesn't take so long, it doesn't cause the hypervisor overhead, and also certain arrays simply do a metadata update to write a page full of zeros, and they can even do that in the background mode as far as I know. So that offloads more from your hypervisor. Then VAAI is not only about SAN, it's also about NAS. And with NAS, the principles are a little bit different, but the concept remains the same. First, there is full file clone, which is essentially the same as XCopy. The only difference is it cannot do storage vMotion or storage operations for live virtual machines. But instead, what we get with this command is that cold clones or deploy from template are offloaded to the storage hardware. So this is not causing higher CPU consumption on your hypervisor anymore. Also, this primitive is the base of VMware View Composer, and you can have your linked clones created directly by the storage array and not by the ESXi host. And as far as VMware is writing in their documentation, this is also extended to vCloud. So you may consider it for your cloud as well. Then there is fast file clone, which essentially offloads snapshotting cloning operations to the NAS array. And there is reserved space, which is quite an interesting primitive, which allows us to create thin provisioned VMDK is written here. I guess it should be data stores. No, actually VMDKs. Sorry. On NAS data store previously, you could only create a thick provisioned VMDK. Right now, VMware supports creating thin provisioned VMDK and also offers multiple instruments to monitor that thin provisioned VMDK and also to monitor thin provisioned stuff you have on your NAS storage. Then let me jump over to the next slide and actually talk about thin provisioning improvements. First of all, with the VAAI, we get extended statistics on the storage utilization. Previously, vSphere client could not see inside the thin provision data store actual storage utilization. So you had your threshold and you had your limit, nothing else. Right now with VAAI, you can see how much storage it actually consumes, which is a really neat feature. Then there is thin provisioning stun, which is a good thing for thin provisioned data stores. When data store is full, previously all the virtual machines running on it were paused. Right now with the thin provisioning stun, only the virtual machine which demands more space and requires more space allocated is paused. Other virtual machines continue to run just fine. So it shouldn't be a big deal for far-seeing administrator, but we all know how it happens in the real world. So this is a really good thing to have with thin provisioning. Then there is space threshold warning. So when you have, let's say, 30% of your thin provision data store left, you get a warning that, okay, we're actually running out of space. Previously, that was not available in ESXi. And of course, dead space reclamation. I'm not sure if this option is now automatic or manual, because initially VMware made this option automatic. So basically, we had a thin provision data store. When we remove a virtual machine, VMware automatically reported to the storage array that, okay, now these blocks are not occupied anymore. You can actually reclaim them and maybe provision for something else. There were some technical issues with doing that automatically, primarily performance-oriented. And right now, this procedure is manual and is launched after you do something to the thin provisioned data store. And with that, I think that's all for VAAI. As you can see, that is also a great feature which makes it possible to unload your hypervisor and actually load your storage. And just wanted to quickly mention that StarWind software, StarWind Virtual SAN, supports both VAAI and ODX and is able to offload that overhead burden of your hypervisor. And with that, I'd like to thank everyone for viewing the presentation, and we'd like to move to the questions and answers session.
Yeah, thank you so much, Max and Aidan. Thank you guys both for your presentations today. Much appreciated. Thank you for taking time out of your days to do that. So as Max mentioned, it's time for the Q&A. So if you have a question for Max or Aidan, please feel free to submit it via the Ask a Question box appearing on the left-hand side of your console. I'll give everybody a minute or two to start asking their questions. But in the meantime, you can contact StarWind for more information. I'll keep the information up on your screen now throughout the entire remaining portion of the webcast. So that way you can copy down the information in case you have any further questions. So let's see here. A question that came in, this one was for Aidan. This comes from Joseph. He's asking, so Aidan, the ODX is enabled by default on server 2012 R2. Are there any enabling steps on the SCVMM R2 side for the Dell compliance side, or are they also enabled by default?
They should be all enabled by default. So it's nice and easy. You just take advantage of it. So if you have the support, it's there.
Question here for you, Aidan. This person's this comes from Manfred. He's asking, I understand that ODX is only used in sorry, let me read this again. I understand that ODX only is used on SCSI connected VHDX. Is this correct? And what happens if you clone a VM with a VHDX connected to a IDE? Will I get benefit from an ODX?
If you clone, can you give me that scenario again? If you
No
clone
problem.
machine,
if it helps you, you can go to the question section. It's number 7. It's from Manfred. So he's saying, what happens if I clone a VM with a VHDX connected to an IDE C drive and a VHDX connected to an SCSI?
Okay. So the cloning operation doesn't really care. It's the cloning operation's being done at the host level or the storage level, so it's irrelevant what the files are and where they are connected. So the whole process should be fast.
Question here: does ODX provide similar to ATS in a VAAI regarding locks?
Max, do you know the answer to that one?
I'm not sure. So I know that ODX currently does not facilitate something like that. So Hyper-V still utilizes SCSI-3 persistent reservations for the LUN.
Yeah.
And the idea Microsoft evangelizes right now is to use storage spaces and to use scale-out file server to overcome that. So far I've heard multiple people just using one cluster shared volume per virtual machine, which is quite messy when you have a lot of virtual machines. And yeah, it sounds insane. And in StarWind, so far we recommend to use one cluster shared volume per Hyper-V host. Since we're running hyperconverged, we essentially do local I/O and don't go to any other hosts for I/O. And we're working on not ODX support, but this will be a more interesting thing. The idea we try to implement is to do VVols for Hyper-V. So essentially have automatically carved out LUNs for each virtual machine you provision, and also get away the management part from the administrator. Instead, just do all the management on the StarWind level and on the Hyper-V level.
Question here. Can Hyper-V use ODX when the LUNs are presented directly to the Hyper-V hosts as CSVs without using SMB 3.0 and the SOFS cluster?
Yes. So the primary scenario is where you are presenting the LUNs to the hosts, either as just ordinary LUNs or as cluster shared volumes. So you don't need a scale-out file server to do it. In fact, in most scenarios, you're not going to see a scale-out file scenario where ODX is being enabled. However, if you want, you can front or present a SAN as a scale-out file server. But you'll not see that very often. But you do not need SMB3 or storage spaces or a scale-out file server to use it. It's just a traditional host connecting to a LUN in a SAN that has ODX support.
Max, what do you think are the benefits of ODX in a hyper-converged Hyper-V environment?
That's a really interesting question, because technically, let's imagine a two-node hyper-converged environment. So we have two hypervisors and two SANs essentially being the same servers. With ODX being enabled, the overhead we're eliminating is, I would say it's still there, but it's significantly minimized. And what I would also do, I would ask Aidan. Aidan, what do you think about hyper-converged environments and hardware offloads? Because we're essentially offloading these operations to the same hardware. Will it do us any good?
Yep. If the hardware is tuned for those operations, then yeah, it should offer benefits, and it's going to be that sort of solution is great in a small medium enterprise because it drastically reduces the cost of the infrastructure and potentially the complexity of the infrastructure by bringing it all down to a single tier. So with everything doing specifically what it's tuned to do on the kind of hardware that it's working with, then you should be able to see enhancements in the scenario that you're talking about. That'd be my opinion anyway.
No, I appreciate it. Thank you so much, guys. Thank you so much for answering everybody's questions from the audience. So appreciated. Thank you, everybody in the audience, for joining us for today's webcast. Appreciate you taking time out of your busy days to do so. Today's webcast has been sponsored by StarWind and brought to you by Redmond Magazine and redmondmagazine.com. Thank you all for tuning in. We appreciate that, and hopefully you'll tune in for more webcasts in the future. But thank you so much, everybody, for attending, and have a great day.
Thank you. Bye-bye.